Hello, hello. Oh, Okay. Okay. There we go. Okay. Okay, there we go.
Whoa, the sounds.
Yeah, let me turn off the.
Whoa, the sounds.
Yeah, let me turn off the. Are you listening to the stream as well?
No, I hear it via you. The sounds. Wait, I heard my own voice.
Yeah, let me turn off the. Are you listening to the stream as well?
No, I hear it via you.
Oh, sorry, it's me. There we go. Sorry.
But I heard my own voice. But yeah, this is okay. I need some time because apparently my Skype account is. Oh, maybe. Okay, let me try this.
Yeah, because you have to. Yeah, just search for Christian live stream.
But I'm having trouble signing in.
No problem signing in?
Yeah, so I asked to change my password
on
my Microsoft account, and now it says, this task is temporarily unavailable because an incorrect password was entered too many times.
Oh. That sucks.
Yes. Yes.
But okay, but maybe this will work because now I have you. The question is, I wonder where your voice is coming from. Is your voice coming from my speakers into my microphone? Or am I also sharing my computer audio? That's what I'm wondering, because actually we might be able to. So I'm on Skype with my computer, and then we are on Zoom together. Like it might work. Could you just try to say something?
I know.
Like it might work. Could you just try to say something? No, I think you're picked up by my microphone.
Really?
Yeah.
Oh boy. Okay, I will try again. Okay, I still can change the password.
My computer is going crazy running Zoom and Skype at the same time.
Oh my god. The Skype. I haven't used it in ages, but I can't change my password. That's the frustrating part.
Oh, this is so annoying. But can I like share my audio, my computer audio in Skype, on Skype? Like I have share screen. I also want to audio and video settings. If I could share my speakers, audio, no. No, I can't like, this is so sucky.
Check. Oh. Wait, I have an idea.
You do?
Yeah, let me try something. They also don't tell me when
Why is it so fucking hard to set up streams? It's so annoying. Why hasn't anyone solved? Well, I guess someone has solved it, but I see this every time someone tries to get into streaming. They go through this whole thing of trying to figure out how to do it. We have to use Skype because I'm not able to share my. When we use Zoom, we're not getting any system audio in Ecamm. That's what I was trying to do, but there's like nothing there.
Oh, I think I know what it. Oh, maybe. I'm not sure. Wait, let me check. Because there's also this Zoom audio device thing that might be the one taking all the.
Oh, but it's like I'm running Zoom on my laptop where I'm running Ecamm, and all the audio is there, but Ecamm isn't able to capture audio from the system. There's like an explicit thing there, like system audio, and when I turn it on, nothing happens. It doesn't pick up anything from the system. Weird reason. But aren't you able to get Skype running?
No, I can make a new account. Let me try that.
Yeah, I think you can use your phone number for an account.
Oh yeah. You may already have an account.
Yeah. Bum ba-dum bum 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 ba-dum bum bum. Oh my god, we're losing half the stream with this. So typical.
I should get it gold now.
Yeah, super weird, super weird. But yeah, let's get you running with Skype and then we should be good.
Yeah, I'm waiting for an SMS to verify.
Cool. I've seen some really cool new streaming services. Everything runs from the browser and stuff. It's really cool. Maybe we can search for eCam and Zoom. They should have a Zoom integration. Use eCam Live's virtual camera important. Ensure that you have a related virtual Zoom and blah blah blah. Virtual camera feature allows you to send the output of eCam Live to most. Oh yeah, but that's like use eCam. Well, eCam Live doesn't have the same automatic integration with Zoom that it has with Skype. It's still possible to use it. Blah blah blah. To do this, you simply need to use the screen share mode to broadcast. Yeah, but I'm not. It's not sharing my audio. I wanted to share my audio. So when using screen, you can also broadcast the max system audio. For example, sound from a video in a web browser will be broadcast to your audience. But it doesn't do that.
Wait, but are you sharing your screen?
Yeah, or I did.
Where in audio you need to set speaker to stay in the system? I'm not sure if that's the case. I'm still waiting for an SMS from Skype.
Oh wait, no. Hey, it suddenly worked.
Oh.
Let me stop Skype. Hello. Yeah, now it's working. Now it's working. Awesome.
Yay!
Yeah, you fixed it, Ives. That's why you're the founder and I'm just an employee.
That's not how it works.
Oh, okay. Let's see. We should be good now. Let me just see what I'm actually sharing here. So I'm sharing the app. So let's blow it up. Blow it up. Okay, so we have that thing now, and if I share my screen now on on Zoom, and then oh shit, there we go, and then I have Ecamm there. It's displaying my screen. We have Codesandbox there. I think the audio is a little bit loud. I should take it down a notch. Try to say something.
Hello.
Okay, this is great. Okay, we solved that. That's nice for next time. Okay, so what I wanted to talk about, Ives, is that I've been exploring state machines in Overmind for some time. And I have also been exploring state charts and stuff, but I think state machines is a way that's a little bit more approachable for Overmind. Not that state charts doesn't work, but there is this way of kind of integrating it more into what's already there. So I thought I would just show you how it works, and then we can talk about what it actually solves. Let's see. So let's create an app where we have we import. What should we import? Let's have some initial state. Import state from state. I should probably prepare this a little bit, but I didn't.
That's fine.
Foo bar. Then we add our state there. And then we'll do the super trick, declare module Overmind.
The super trick.
The super trick. I config from Overmind.
In the Codesandbox code base, we don't do it like this, right? We export Overmind in app/Overmind, I think.
Yeah, we do explicit typing. But I'm wondering why it's not picking up the type definitions. Is it don't tell me it's don't tell me it's the thingy. It does seem to. Oh. It's the typing service.
Access denied.
Access denied.
Oh, that's the one. Okay.
Yeah.
Today is a perfect day.
Everything's going to hell. Oh my god. Okay. But yeah, I'm glad I got to share the pain of the typing service filling up. I'll just write some more code while you.
Yeah, I think it should work now.
Let's add an actions file. Const action. Oh, sorry. Change foo action. Blah blah blah. Action. Yeah, of course it doesn't know where that's coming from now. import action from overmind. Okay, I'll try to refresh and see if we get the typings. There we go.
You.
What's this? Wow. What's happening here? Parsing error cannot read property map of undefined. Is it?
Where is that?
The index file?
ESLint. ESLint getting crazy.
Yeah, that's weird.
Yeah, that's true. That's really weird.
Oh, it's really going wrong here. You see that? Or maybe I've typed something wrong here. Or it might be like a white space. You know, Norwegian keyboards, they have this insane white space thing that I always bump into. What the hell's happening here? Oh, export. That's it. Sorry.
We're getting somewhere.
Yeah, but that was an interesting one. Okay, so let's add. Let's just start an overmind instance. We don't really need to do React and stuff here, but yeah. We need our config, which we're going to grab from our app. And then we are going to add the dev tools. Dev tools, localhost 3031. Else, yeah. Let's see. Oh, we already have it there. Foobar.
Oh.
Magic.
Oh, that was quick.
Yeah. Okay. So the idea is that typically when we look at examples of state machines, they are these very specific things. So for example, you have a challenge with some complex interaction related to drag and drop, use a state machine for that. Or you have this timer, or you have some lights, or it's very small scope things. We never talk about state machines as in the conceptually related to global state stores like Redux and Overmind and MobX State Tree. Like we haven't found a way to kind of express the whole application using the idea of a state machine. At least I haven't been exposed to that and found it very challenging. Because even though like XState beautifully expresses state machines declaratively using an object, there's limits to that as well. Like it will kind of blow up the whole thing if you would use it for all of Codesandbox, for example.
Yeah.
But there are some really great values in using a state machine, and I thought we were going to try to kind of get to that and see if we can actually integrate state machines into a more typical global state store like Overmind. So one thing we typically do is like authentication. So we would have like a user, for example. Let's just do a username string, but we might not have the user. So we do something like that, and then we have is authenticating, which is a Boolean. And we might have like an error, for example, which might be a string, or it might not be there, depending on our state. And this is like, I guess you kind of recognize this in Codesandbox. This is how we write a lot of our state. And I think a lot of people write their state like this. But the way you would rather express this with a state machine is that you would rather do something like states. I'm calling it states. And then you would say, I am authenticating. Or I am authenticated, or I am unauthenticated. Oh, sorry, I'm using parentheses here. So you rather create these explicit states. And the thing is, when you have these explicit states, it actually, and this is something I've learned exploring this, it heavily affects the way you do typing. So in this case, we can rather say that, no, we only have a user when we're actually authenticated. So there's no question about that. If we're authenticated, there is a user there. And if we are unauthenticated, we can say that we have some error there, for example.
Yep. Yeah, that is really nice.
Yeah, so you kind of ensure that you're not like David talks a lot about these impossible states, and this is kind of what it's pointing to. Like your is authenticating is true at the same time as you have an error. Maybe you forgot to remove the user. So you get into these impossible states. And the way you would express this as a state machine in Overmind is that you pass it these states. And then the first argument is basically going through what states do we have and what states can we transition into. So when we're authenticating, we might go into authenticated or we might go into unauthenticated.
Yeah.
When we're authenticated, we might end up in unauthenticated because you might be logged out for some reason, or explicitly the user logs out. And then if you're unauthenticated, you might go into authenticating again.
Yeah.
So you explicitly describe those things, and then we need to give it the initial state, which is
unauthenticated.
Yeah, that depends on how we want to do it. We could do unauthenticated, and you explicitly like go into authenticating, but typically in apps you start in authenticating because you're always checking, are you already logged in?
Fair enough.
Fair enough. Cool. And then, yeah, let's remove this state.
It's angry about the state.
Yeah. Okay, so now we are in authenticating. And the thing about this related to how should we do this? We have this action, maybe we can call it like auth changed or something. And when auth changed, we might have a user there. I'm just doing this very straightforward. Or we might not have a user there. So imagine this being like you're calling some API that like you have some, so for example, Firebase, you have a typical callback like this, which is called whenever the authentication is changed. So you would do something like, if we have a user, you would say state, and then you would transition.
Oh, cool. It also infers which types are possible? Oh,
yes.
No.
So you would transition into authenticated, and it knows when you try to transition into authenticated, it knows that you need a user here.
That is super cool. I'm also wondering whether it would be, might be hard, whether it would be possible to, in the action, to make like an auth changed action for the authenticated transition, authenticated current state, for the unauthenticated current state, so you don't have to do the username string or null in the action types too. Then like it can be inferred. I'm not sure. Oh no, but
oh, sorry, I was writing code, so I wasn't paying attention.
Yeah, so I'm thinking, like the auth changed, whether it would be possible to make that dependent on the state you're in. Like you can have an auth changed action for authenticated, you can have an auth changed action for unauthenticated, and you can have an auth changed action for authenticating.
Yeah.
But then the types of the store is typed based on it.
Yeah, like that's the tricky thing. Like, how do you decouple the logic from the state? Like, as you said, should you have one version of the action based on the state you're in, or like in X state, you kind of bind to. I'm not sure how it works there, because you don't explicitly call the action, you always transition into something, and calling the action is like a side effect of a transition, the way I understand it. But that wouldn't work for Overmind, because you have this very explicit concept of actions you're calling.
Mm-hmm.
So yeah, it's really interesting how you would do that. But in terms of being like an addition to Overmind, you kind of have the actions already, and then
That's
you have
true.
to introduce the state machine concept inside there. So that's a way you can do that, is by doing it like this. But yeah, it's a really good question, and that's the challenge with state machines. Is like you have these existing concepts, and you want to find a way to use their concepts in existing solutions. Because if you're going to be perfectly pure in the idea of a state machine, you kind of have to build a library from scratch, I think. Or you would have to sprinkle it around outside your general state management, like for specific component challenges and stuff, which is totally valid. But it's interesting to see how it can be integrated, because the interesting thing here is that whenever this auth change runs, you don't know what state you're in, right? So for some reason, auth changed might be called again with a user, and you're already authenticated. In that case, it wouldn't allow you to transition to that state. It would basically ignore setting this, unless you said that if I'm authenticated, I'm allowed to move back into authenticated.
Right.
So
But
you
what
would,
does it
yes,
like throw an error?
No, it silently ignores it. Because
Fair
this is
enough.
the thing, like you have to imagine, like you have no control of when your logic is being run. What you want to do is protect your logic behind these transitions and matching the current transition state. Yeah, so that's basically what we're doing here. We're protecting setting this user behind this transition state, so it only runs this if it's allowed. And then you can imagine, what if you wanted to do something related to authenticating? Maybe you want to start to listen to something. So then you have some kind of effect or something. So you would say like effects, listen to this thing, whatever. And the point is, it's the same thing. It wouldn't move you, it wouldn't run this callback unless you're actually validated to move into this state. And then the point is that it's not only transitioning into state, it's also when it changes the state. So for example, here we say that we set the user, but if for some reason you were unauthenticated, it would actually remove the user from the state for you. And this is also a thing that often happens in applications, is that we basically move into these new states, but we're not cleaning up the state that was related to a different transition state of the application.
The set loading false, error is null, all those things.
Yeah, you have to kind of reset everything. And that's also something this API does. But then we can go deeper into this. We can say like, okay, so when you are authenticated, we want to fire up like a page or something, home, I don't know. And this can also be like a state machine. So you have this home page where you have different tabs, for example, or whatever. And then you would, let's see, let's just call it home. Type states current. Yeah, maybe we could call it like dashboard or something. And then you are like home. You can imagine having like the main overview of your app where you have different pages, different tabs or something. Then you would export. Yeah, let's just call it state machine, states, blah, blah, blah. What did I call it? Home. Then you can move to admin. If you're an admin, you can move to home. And let's start on home. And then you can say, okay, this is going to be type of import state as home. Type of home. I'm not sure why it's angry. Is it angry? No. Cool. So now you're saying that whenever we transition into authenticated, we want to include a new machine. We want to include the home machine. So what you would do here now, you can see that it starts complaining. And we will actually, from home, we would have to include home. So that when we move into, maybe we can just do that now, auth changed. Maybe we can actually run an action here. Let's see, auth changed.
Ooh.
Yeah. Bob. Let's run it.
Bob.
Ooh.
Ah.
Yeah. So now
current set user.
Yeah. So now we see that it sets the user and it sets home as a new state machine. And then we're authenticated. And then we can also see it.
Okay.
So now we have kind of, what this shows is how you're able to like dynamically nest state machines, basically. And what's interesting about this feature is that if this home thing, let's imagine you want to open admin, for example. So this is where it starts to get interesting, because now we have this other action, which is basically just going to transition from, it wants to transition into the admin state of home, right? Now the thing is, we don't have home here.
No.
And the reason is that we don't know if we're authenticated.
Yeah.
So first we actually have to check if we're authenticated.
Oh, I see the matches.
Yeah, and then auth state, and then we can, then we get the auth state, which shows us that, okay, if we are authenticated, it means that we actually have a user and we actually have home, because the typing has kind of taken care of that for us. So this is like coding wise, ensuring that what we see here is what we have available, and then you have the typing on top of that, which is also helping you.
Then you can do transition admin.
Yeah, exactly. Transition admin, and it doesn't. Oh,
yeah, because it's the root state that. Yeah, I see.
Yeah, and this is the thing that yeah, let's move on with the example. So imagine that on admin. Let's make this a little bit more technical. So we have admin, and on admin we want to have, okay, so maybe I can introduce this. So sometimes in a state machine, it doesn't matter what transition state you're in, you just have some base state. So for example, in admin, you might have a, let's call it admin. It's a list of users. And you don't want to remove those users when you move between home and admin. You want to keep that list of users, right? But if we were to introduce the users here, those users will be removed when we moved into home. So what you can do here is that you can have base state.
Oh.
And the base state is the third argument, and it's always there. So it doesn't matter what you transition in between, you will always have users available to you.
So you will always have, in home, you will have it available, and in admin.
Yeah, exactly. So what might happen here when you transition into admin, you might want to, let's call it admin state. You might want to go and grab some users. So users equals await effects API get users, for example. Let's imagine we have that. Yes. So the thing now is that we're doing something async now. So you might think that you can just do admin state users equal users. But the thing is, this is the really tricky thing about state machines is as soon as you do something async, especially when you do nested state machines, it's like, okay, you do something async now, but now at this point in the code, all kinds of shit might have happened. The user might have been unauthenticated, for example. Or maybe the users could only be set on admin, for example. Maybe that would be a better example. But you weren't on admin anymore. You had changed to home, for example, or something like that. So the point is that you really do not have, and this is where we go wrong with our code very typically. And I think this points even better to the impossible states thing. It's all these edge cases where we do something asynchronous and we go into that asynchronous point knowing the state of our application. And then we want to continue and we assume that we are still in the same state after that asynchronous code has run. But we don't really know that. And that is where you have these edge case bugs. For example, you can have something crazy where you go in and you grab a set of users and then suddenly you're unauthenticated. But the code is still adding those users because your code doesn't care if you're authenticated or not, for example. And then maybe when you're unauthenticated, maybe someone else tries to authenticate with a different account. And then suddenly you have the users of the other user in your client-side state store because you didn't protect setting them. And that are the kinds of bugs that is like impossible to figure out beforehand. And it's really, really tricky to understand when users are saying like, hey, I logged into my account and I was seeing the users of this other user. Like what happened? And like trying to figure that out is super, super difficult. So the way this works in Overmind is that every time you do something asynchronous, you're not allowed to change any state anymore. But what you can do, so what you would do, like to be very explicit here, you would actually check, am I still authenticated? And if I am still authenticated, sorry, I can actually write this much cleaner. We don't need all these thingies here. So we can do it like this and like this. Oh, did I do?
Looking at it.
Oh, did I do? Yeah. It's more like this. Anyways, so we have to check if we're authenticated. If we're authenticated, in this case, we don't really care if we are on the admin or the homepage, but we might be. But the point is that this is how you would like correctly ensure that you are in the correct state. And at this point, you would be able to let's just write it out completely. So auth state, home matches admin, admin state dot users equals users. I'm not sure what it's complaining about here. What are you complaining about? Return type. Oh, yeah, it's because we're async now. There we go. Anyways, but one thing that state machines often do is that when you have nested state machines, they're like children of their parents. So what they do is that whenever a parent state machine transitions out of a state that has a child state machine, they dispose of it. So even with like this very flexible API, you can do, you wouldn't have to do this. You could just check if return admin state matches admin, for example. Oh, admin state. Yeah, and then we could say admin state users. So the thing is, what if you were unauthenticated? And it basically, you're kind of still on admin, but you're unauthenticated. Well, the thing that happens is that when you're unauthenticated, we're transitioning away from the home state machine.
Yeah.
We're moving down here, and Overmind understands that. So it disposes of the home machine, which means that if you try to set any state, or basically if you try to transition or run a match on a machine that's disposed, it doesn't run the logic.
Oh, that is so nice.
Yeah,
that is really nice.
So the thing is, like, from one perspective, it's like super nice to have this declarative way of managing state machines. And this is kind of crazy because this is an imperative approach of managing state machines. But again, we're so used to doing this imperative kind of code, and it's really interesting, like, how does it actually look like to get the power of state machines in an imperative API? And you get these yeah, it's really neat. But like the biggest problem, like the big question is, how do you feel about this? Like, how do you feel about every single action needs to first present, this is the state I need the application to be in for this logic to run. And then whenever you do something asynchronous, you again have to check, okay, am I still in the state I was in before I did this asynchronous thing? Which is a lot of, you could call it boilerplate.
Does Overmind also check, like, for line 23 and line 26? If I would not do it in a matches, would Overmind check, is this, whether it's, would it throw an error or?
Yeah.
Okay.
So basically what happens here is that when you run, yeah, so we can start here. So if we were to run Overmind in strict mode, which is part of this API.
That's very React-like.
Yeah, exactly. So what would happen here is you wouldn't be able to change the state here coming in here. We get an error. If you run matches, it allows you to change the state. But as soon as you do something asynchronous, you're not allowed to change the state again.
So it checks for promise or something?
Well, basically, whenever this callback is called, it enables mutations on the, I call it the mutation tree that's passed in here. And then it creates like this, what's it called? This micro task. Like it's basically a promise resolve where it blocks the mutations again.
Yeah, I see. Then it's so it's for a very short time it enables mutations, and then like a tick later it closes mutations again.
Yeah, so like the most immediate thing you can do asynchronously is a micro task. I think it's called a micro task. So, and it's a queuing system like everything else in JavaScript. So it's not like in certain scenarios you might be able to change the state doing something async because that priority of that async task was before we started blocking mutations, for example. That doesn't happen. It's like a
but that's nice because well, the biggest thing I don't like about what we currently write is that we have these all or null checks.
Yeah.
Because of that, it's harder to enable strict null check. And I'm really curious how you would write this in a component, like how you would fetch this state from a component.
Yeah, exactly. And basically the way you do it is, I can write some pseudocode. It's like you would have state equals use app state or something like a hook. And the thing is, like what we're doing here, we're isolating the action. So the action doesn't know anything. It can run any piece of logic related to any state or whatever, which is a good thing and can be like a curse as well. Sometimes we do want our logic very tightly connected to our state. But anyways, so every action just is completely isolated from everything else happening, and it needs to check what's the current state of the app for this logic. And a component is exactly the same, which is very interesting. Even though a component is part of a component tree, when you define it, it's in isolation. Like you might use that component in any piece of the tree. You don't know where it's going to be used. So it's the same principle there, that you would say if state current equals authenticated. And so let's say this is supposed to render something inside home. You would say state home current equals home, and then you would actually do something.
Yeah, you could create, if you want to, you could create a helper function or something.
Yeah.
That would allow you to give like key value, an object like authenticated, and then the component that it should render if authenticated, and then it can give unauthenticated and the component that it should render when unauthenticated, and then the props of that state are automatically the states automatically insert as a prop in the component that's then rendered.
Yeah.
But this reminds, I do like this system because it reminds me a bit of how Rust handles memory management. They have changed the whole way you write code to get safe memory management, to include the semantics of like allowing the borrowing system and mutating system. And it's at first you have to get used to it, to that different style of writing code. But once you are used to it, you have the big advantage that you never have an issue with memory management.
Yeah.
That's safe. And I feel like it's similar here, where if you start writing your state this way, it might be cumbersome at first, but I think you'll get used to it pretty quickly, and then you are safe from these kind of race conditions.
Yeah, exactly. And I'm reflected on it more this morning, and I kind of compare it to washing your hands, because you writing your code this way doesn't give any immediate value. It actually feels the opposite. Like, oh, I have to write all these additional checks. But the thing is, you won't, and if you're doing it right or preventing some edge case bug, you won't know about it, because nobody's going to report that, oh, awesome, you did this check, so I didn't end up in this bug. So it's like washing your hands. You never know if it's going to give you value or not. You just do it because you know it's the right thing.
Mm-hmm.
But what I really like about this is that you actually think about the logic you're writing. Like, what is this logic for? When should it run? I'm doing something asynchronous here. The world might have burned down in the meantime. How do I ensure that what I'm doing after this is properly taken care of?
Yeah, because you can, like, in a different paradigm, like what we are doing right now with the Codesandbox code base, you can, after every async check, you can do like if state dot, and then you can check whether some things have changed before moving on.
Yeah.
But it's not a requirement, and because of that, it's much harder to because of that people don't do it. And with this system, it becomes the norm, and that's pretty nice, I think.
Yeah, exactly. And especially if you can enforce it, that's really cool with a strict thing.
Yeah, so
Yeah.
this example, this is something that I would think would be really interesting if you would be able to write it in such a way where you can do const or let page and then is
Yeah.
on line 13, and then a function, and then you give it an object with
Yeah.
like authenticating, and then you give it a component, and then that component will be rendered with
Yeah.
the state of that specific state.
Yeah, exactly.
Machine.
Yeah, that's really, really interesting, because the challenge with matching is that one thing is if you're doing this kind of match, which is simple and straightforward, but some matches might be nested. So there are, just like we did previously, you have like, okay, if I'm in this parent state, this nested state, and this third nested state, so these matches can become quite complicated. But having a way to, as you say, kind of isolate this condition, like, is my app in this current state? And then you just write the code for what should be running at that point.
Yeah.
Instead of I'm having it very explicitly now.
Because that's the kind of thing that I don't know how people solve with React yet. Like the amount of if checks in a component.
Yeah.
If in case of overmind, you can, like, I do understand if you set specific props, like this component only can get a user.
Yeah.
And not a null value. But in our case, we directly get things from the state.
Yeah.
And because of that, every time, if we would have strict null check, every time we would have to do an if check, if user is not null, and then only continue then, which is very cumbersome if you have to do that for every object.
Yeah. Yeah, exactly. And that, I guess that's one of the benefits of using pure React, is that I thought about it, like React is kind of a state machine, like a bunch of nested state machines in itself, because it disposes components and does all of this stuff automatically. The challenge though is that you have to pass all the props down. So if you have like a higher up component and you have like 5 levels down, you have something that needs access to state or change some state, you have to pass that as props all the way down. Which is such a pain. But I think, like, just like you mentioned now, if you're able to define a component that requires a specific state of your application, then it's like straightforward again.
Yeah.
And it will still be like safe to move that component to any point in the component tree, because it just checks the state.
It's
Which
conditional.
Yeah, exactly. So yeah, it's really interesting how this stuff works. And here's a little bit more complicated example. So here you can see we're like adding a backlog item. This is the app I'm working on in the mornings. And we have to check, like, when we're adding a backlog item, are we actually authenticated? Are we on the add backlog item screen? is the state of the add backlog item screen valid, or did we get a server error, which means you can submit it again? And given that, we want to transition the add backlog item screen into an adding state. And then we do something async. And then we have to figure out, like, after we did this async, are we still here? Maybe the user clicked back to the home page, meaning you're not on the add backlog item page anymore. Maybe you were unauthenticated during adding that backlog item. We have no idea. So then it does the same thing again. It checks, are we still adding? And if we are, let's do the thing and move on from there. So
one thing is that this is really nested. It can get quite deep in the.
Exactly. That's the thing.
You would need new screens, like wider screens.
Yeah, exactly. So you would kind of want to move all of these three things into a callback, as you said.
Yeah, like a single one.
Like a single one, yeah. But you wouldn't want to create all these, like you wouldn't want to create all these custom callbacks either. Like you would want to have like this generic matching thing, but then you get into issues with TypeScript again. Like, how do you express this kind of nested matching and still get the correct typing back for the state and stuff?
That's good to think about.
Yeah, exactly, because that's the thing. Like, it's, as you say, it's kind of like callback hell. There's a lot of more explicitness checking the state, but it does actually fix these edge case issues and the typing issues, and that we do also have problems with.
Yeah.
Yeah.
Really interesting.
Yeah,
I like the async not allowing mutations the most.
Yeah.
Because the transition makes it possible to do it. Like there would be no other way. Would it be possible to check whether you can make changes after an async action, because you don't have functions like transition. So that's really cool. That's unique to state machines, that you can now do this kind of checking.
Yeah, exactly.
This kind of validation.
Yeah, and I think that's the appealing thing. Like, if you like this or not, it's at least kind of, at least from my experience, quite novel idea on how to bring the ideas of a state machine into this more imperative dealing with async, just thinking more straightforward, like many of us do, in terms of writing imperative logic, but still kind of get the power of the state machine, forcing you to check the states and ensuring that you're in the correct state when you run your logic. Yeah, but like, I've iterated a lot on this, and this is the first time I've seen something that could actually work in Codesandbox as well. Like, I'm not saying like we should do it in any way, but it's possible to do it. It would be a lot of state checks and stuff, but it's an API that actually can manage like this huge app with multiple nested machines, moving between machines, and doing async stuff. Inline. Then
I would like to see. Yeah, I would like to see this in a bigger app. So I will check this. I also have some ideas on the. Maybe we can remove some boilerplates by. I have some ideas, like.
Yeah, like this.
Maybe you can. Yeah, I think there is a way, but I'll think a bit more about it. But I have to go.
Oh yeah, we're over time. Yeah. But yeah, if we didn't have so much problems, I was going to show you something else as well, but we can maybe do that next time.
Next time? Yeah, that would be nice. I also would like to see if this would be able, how we could do testing around this. Yeah, like this kind of unit testing type of thing. Like testing the state. That would be really interesting to find out as well.
Yeah, exactly. Yeah, and you kind of get automatic testing as well, or at least guarding. So because you explicitly say this logic can only run if the app is in these states, and if the app is in these states, I do have access to these. Like TypeScript tells you, you do have access to these values.
Yeah. So that's something that you won't have to test for anymore. You won't have
exactly.
won't have to write a test. If user is authenticated, it only does it then. That type of thing, it doesn't. That's long gone, because that's now built into the state.
Yeah, exactly. And like you have some piece of logic pointing directly to the user. You don't have to test what happens if you don't have the user, because
Oh yeah,
you still have, because you have this explicit, okay, if we're authenticated, we have the user, we know that. So yeah.
Yeah, that's a classic.
Classic, yeah. So
Okay.
yeah, sorry. We'll talk later, Ives.
Yeah, let's do another session on this. I think this is really interesting.
Yeah, let's do that. Cool, bye for now.
Oh, that's awesome. Yeah, see you later.